Whey protein is essential for building muscle, supporting recovery, and maintaining overall health, which is why millions of people around the world consume it every single day as part of their diet. From athletes and bodybuilders to everyday fitness enthusiasts, whey protein has become one of the most widely used nutritional supplements on the planet. But despite its popularity, very few people actually know where it comes from or how it is made. Whey protein is derived from cow's milk as a byproduct of cheese production, and before it reaches your shaker bottle, it goes through a long and carefully controlled journey. A typical modern factory can produce around 10,000 bottles of whey protein per day, and each of those bottles represents a process that starts far away from the factory floor. The history of whey protein is closely tied to the history of cheese itself, since both originate from milk. It's very likely that early humans discovered whey entirely by accident. Thousands of years ago, farmers stored milk in containers made from animal stomachs. These stomachs naturally contained rennet, an enzyme found in the stomachs of herbivorous animals. When milk came into contact with rennet, it caused the milk to coagulate, separating into solid curds and a watery liquid known as whey. While the curds were valuable for making cheese, the whey was often discarded or fed to animals. For centuries, whey was considered waste, mainly because its nutritional benefits were not yet understood. It wasn't until much later, with advances in food science and nutrition, that whey began to be recognized for its high-quality protein content and unique amino acid profile. Scientists discovered that whey protein is rich in essential amino acids, especially leucine, which plays a key role in muscle protein synthesis. This discovery completely changed how whey was viewed, transforming it from a waste product into a highly valuable nutritional ingredient. The modern whey protein production process begins at dairy farms, where cows are raised specifically for milk production. Farmers pay close attention to the health and well-being of their cows because factors such as diet, stress levels, and living conditions directly affect milk quality. Healthy cows produce better milk, which ultimately leads to a better final protein product. These cows are usually milked 2 times a day and can produce anywhere from 25 to 35 liters of milk daily. To improve efficiency and consistency, many farms now use robotic milking systems. These systems allow cows to be milked when they are ready, while also collecting detailed data on milk yield and quality. Once collected, the milk is stored in chilled tanks to keep it fresh. It is then transported to the processing facility using bulk tanker trucks that are specially designed to maintain strict temperature control. Keeping the milk cold during transportation is critical, as it helps prevent bacterial growth and preserves the milk's natural properties. When the milk arrives at the processing facility, it does not immediately move into production. First, it undergoes a series of quality tests. These tests check the temperature, acidity levels, fat content, and the presence of any contaminants or antibiotics. Only milk that meets all quality standards is approved for further processing. Any milk that fails these tests is rejected to ensure the safety and consistency of the final product. The next major step is pasteurization, which is essential for eliminating harmful bacteria and ensuring food safety. There are 2 main pasteurization methods commonly used in dairy processing. The first is high-temperature short-time pasteurization, where milk is heated to around 72 degrees Celsius for about 15 seconds and then rapidly cooled. The second method is ultra-high temperature pasteurization, where milk is heated to much higher temperatures, around 138 degrees Celsius, for just 2 to 5 seconds. Milk treated with the UHT method can be stored for longer periods without refrigeration. After pasteurization, the milk is quickly cooled to around 4 degrees Celsius to stop further heat damage and to slow down microbial activity. The actual production of whey protein begins with curdling the milk. This is done by adding rennet, an enzyme complex that causes milk proteins to coagulate. The process takes place in massive industrial vats, where mechanical stirrers ensure that the rennet is evenly distributed throughout the milk. As the milk coagulates, it separates into solid curds and liquid whey. The curds are removed and sent off to be processed into cheese, while the liquid whey continues on its journey toward becoming protein powder. At this stage, the liquid whey still contains a mixture of water, lactose, minerals, small amounts of fat, and protein. To improve safety and quality, the whey is pasteurized again to remove any remaining bacteria or microorganisms. This additional step ensures that the whey protein will meet strict food safety standards. Next comes the most important part of the process, concentrating and isolating the protein. 2 main technologies are used for this purpose: membrane filtration and ion exchange. Membrane filtration is a cold separation process that uses a series of porous membranes with different pore sizes. These membranes allow carbohydrates, minerals, and water to pass through while retaining the protein. This method helps remove fat and lactose while preserving the natural structure of the protein. Ion exchange technology works differently. In this process, liquid whey is passed through columns that attract and bind protein molecules based on their electrical charge. The proteins are selectively captured, while lactose, minerals, and other components are washed away. Ion exchange allows for very high protein purity and can isolate specific bioactive proteins such as immunoglobulins and lactoferrin. The result is a whey protein with extremely low fat and lactose content, excellent solubility, and a clean, neutral taste. Before these technologies were developed, whey protein powders were far from appealing. They were often insoluble, had a yellowish-brown color, and tasted unpleasant. Modern filtration and isolation methods are the reason whey protein today mixes easily, looks clean, and tastes smooth. Once the whey protein has been concentrated, it still exists in liquid form. To turn it into a powder, the liquid must be dried. This is done using a process called spray drying. The concentrated whey is fed into a large drying chamber and sprayed through a nozzle, breaking it into tiny droplets. At the same time, hot air is blown into the chamber. The heat causes the water in the droplets to evaporate almost instantly, leaving behind fine, dry protein particles. These particles fall to the bottom of the chamber, where they are collected as powder. By adjusting temperature and airflow, manufacturers can control the size and texture of the powder. The dried whey protein is then moved to a mixing facility. Here, it is weighed and combined with flavorings, sweeteners, and sometimes additional nutrients like vitamins and minerals. This step ensures the final product not only meets nutritional goals, but also tastes good. Large rotating drums or industrial mixers are used to blend everything evenly, creating a consistent product from start to finish. Packaging is the final stage before distribution. Empty containers are placed onto a conveyor belt and filled using automatic machines that dispense precise amounts of protein powder. These machines are connected to intermediate bulk containers that store the finished blend. After filling, each container is checked for accuracy to ensure it meets weight requirements. Labels are then applied, displaying nutritional information, ingredients, and usage instructions. A plastic seal is added and heat-sealed to create an airtight closure that protects freshness. Before the product is shipped, quality control teams test each batch. This includes checking taste, texture, solubility, and consistency against a gold standard. If anything is off, the batch is sent back for adjustment rather than being wasted. This final check ensures that consumers receive a product that is safe, effective, and consistent every time. Today, whey protein plays a major role in nutrition across all age groups. It is used not only in sports supplements, but also in infant formulas, medical nutrition, and products designed for the elderly. The goal of modern whey and performance nutrition companies is to provide high-quality products that support better health and improve nutrition worldwide. And now that you know how whey protein is made, you'll never look at your daily scoop the same way again.